Hello everyone. So let us discuss one more example in case of paging techniques or how we are performing this memory management. Mapping methodology using the paging. So here, whatever the address that has been generated by the user is said to be the virtual address, and obviously that virtual address consists of 16 bits because we are working with the 64K of virtual address space. So each and every address will be represented with 16 bits. So that is what given here. Say for example, and here we will be having 16 number of pages, isn't it? So we will be having 16 number of pages for the virtual pages, and for the main memory we will be having 8 number of frames. Okay, so according to that, we can divide this virtual address into two partitions. One is for representing the page number, and another one is for representing the page offset. So which means how many number of pages we have here? We have 16. So 4 number of bits will be allotted for page number. 4 number of bits will be allotted for page number. And here the remaining 12 bits will be allotted for representing the page offset. So what do you mean by page offset? So in the suppose if you want to execute one particular instruction like move register 0, okay, so where this instruction is available in one page. So this instruction is available in page 0, but page 0, what is the size? It is 4K, which means many number of locations will be having. So what could be the correct location of this instruction? We will be having many number of instruction in that same page. So what could be the correct location of this instruction? So from the starting address of the page, to the correct address of this instruction is said to be the page offset. The distance between the starting address of that particular page to the address of this instruction is said to be the page offset, right? So we are just representing with the help of 12 bits for page offset and 4 bits for page number. So here, and again coming to this one more bit, this is actually the page table. As I told, only from the page table we can get the frame number information, and according to the frame number we can access the content which is available in the frames in the main memory, isn't it? So one more bit is added with this frame number, which is nothing but, is it a valid or invalid? So how come we are determining that it is a valid? If this particular additional bit is set to 1, then this page is valid. So what is the meaning of page valid? If this page is available currently in main memory, then we can say this page is valid. If this page is not available in main memory, then we can say this page is invalid. Okay, so this additional bit will give you the information whether this page is available or not with the help of this valid bit. So if this bit is set to 1, then the page is valid. If this bit is set to 0, then this page is invalid if this page is not available. Okay, so what we have to do, we have to move that particular page from disk to the main memory, and afterwards we have to make this bit to 1 because that page is available at that time. Okay, so if the page is not available, then we can term it as page fault. Okay, page fault. So this, the instruction, say for example, if you are giving this particular instruction, so its page number is 0010, which is nothing but page 2. So we are going to find out what could be the page 2. So in this page 2, we have the frame number that is 6. We have the frame number that is 6, that is 110. So everything has been represented in binary format. So 110, which is nothing but 6, and we can check with the additional bit, it is valid, which means this page is available in main memory. So we are searching this frame number 6. So what is the address we have, and this same offset value will be copied onto this offset of this frame address, that is physical address. So physical address will also consist of 16 bits, and the first 4 bit will be used for representing the page number, and the remaining 12 bits will be used for representing page offset. So here we can call it as a frame offset, and this one is a frame number because we are finding out the physical address. So it is a frame number and frame offset. So the page offset value will be copied as it is into the frame offset, so that in the same distance we can find out in which location this particular instruction is available. So we can find it easily in the physical address with the help of the frame number as well as that offset value. Based on the offset value we can find it what is the specific address of that instruction. Okay, so here this additional bit in the page table which is used to mention whether it is a present or absent bit, which is used to represent whether this page is available in main memory or not. If it is available, then this bit is set to 1, otherwise the value of that bit will be 0. So next one is structure of the page table, which means how could be the entry of that page table. So how could be the entry of that page table. So each and every entry in that page table will be consisting of these field information. So how many fields we have? So let us see. First one is page frame number. So that frame number we can get it, right? And the next one is present or absent bit. So this field is nothing but it will provide the present or absent bit, which means that particular bit is set to 1. We can say this page is available in main memory, otherwise it is not available. Okay, and what is the next field? It is nothing but protection field. So this protection field is used to protect this particular page from any unauthorized users. Okay, so this protection bit, so there are actually 3 ways of accessing. One is read access, write access, or execute access. So we need to mention which kind of access going to take place with this page. So if it is a write access, then so we have to allow or any other access could be restricted by the particular user. So this should be known by using this field, that is protection field. Suppose if the execute access is not valid, suppose if the writing access is not valid, so if any of the access is restricted by the user, so that can be known by this field, protection field. And the next one is modified field. So what is a modified field? So if this particular page is allowed for writing operation, so whether the content has been modified or not, so that can be that information can be given by this field, that is modified bit. If it is modified, then we can say it is a modified bit, and this bit will be set to 1. This bit is also said to be dirty bit. If the content has been modified, then we can say this modified bit is set to 1, otherwise it is also called as dirty bit. And the next field, which is nothing but referenced bit, which means this page is referred or not. So if it is recently referred, so from this field we can come to know about the information whether this page is highly referred, so frequently used page, or this particular page is not in use for a long time. So with this information we can this particular information plays a major role while we are doing the swapping operation in between the pages. Suppose if you want to get any of the page that is available in secondary memory or the disk to main memory, so any other page that we already have, any other frame that we already have in the main memory should be swapped out. Which page you need to select it, so you can get that information with the help of this reference bit. So if it is highly used, then we can choose any other pages. If it is not in use for a long time, then we can go with this particular page. So based on that reference bit information, we can decide whether this page has to be swapped out or not. And the next one is caching disabled. So which means cache memory which is used to hold some few information which is frequently used. So if the information is not actually getting from the cache memory, so if you're getting directly from registers or from the main memory, and this particular field will be disabled, so that is what caching disabled. So for this page, the caching disabled means you need to represent this bit as to 1. So like this, we have several fields for each and every entry of the page table, which gives you a lot of information about the particular page. Thank you.